Authored and co-authored 90 books, monographs, articles, and throughout the years. Wow, it's amazing, isn't it? And she always asks me why I go back 17 years to the book that we call the Purple Book. Look at the head shaking, Peg. Now you know why I go back 17 years ago. I see this as a time in our history when we started saying that we need cognitively demanding tasks, high-level tasks. And those that had multiple entry points for students. It's about letting all students in to task and solving them at high levels. So it also lays out ways of maintaining the cognitive demand of tasks via our questioning, providing wait time, listening carefully to students. So that's 17 years ago. It's pretty interesting. Then she co-authored, along with some other colleagues of ours in the United States, the Principles to Action, when NCTM decided, wow, there's effective teaching practices, and it's time for us to bring together 30 years of cognitive research on facilitating questions, okay, productive struggle, okay, engaging students. And they pulled these together, and NCTM gave us an illustration of good practice, effective teaching, okay? At the same time, though, Peg and Mary Kay Stein put out the 5 practices and said, gee, it's incumbent upon us as teachers to plan more effectively so that we could spend our time during lessons listening to students, monitoring their progress, and ensuring that we help students put out their thinking and then help them make connections and consolidate their ideas, okay? So that was laid out for us. And that brings us to, it's time to now take action. The 2 new publications by Peg and her co-authors just released, in fact, this month. It's time for us now to take action and say, what does this not only look like, these effective teaching practices, but how do we kind of move it, start doing the work, and what will we see and hear? So today, we have the great pleasure of hearing from Peg, and she'll be talking about productive struggle. Why do all students have the right to be challenged? And how do we ensure that it remains productive? Okay, so that we're not coddling, but instead we're challenging, but making it possible for students to move forward. So it's my great pleasure to introduce Peg Smith.
Thank you, Val. Thank you for that introduction, Vic. I want to give a shout out to Fred Dillon, who's sitting right here, and Steve Miller, who are co-authors of the high school version of the Taking Action book. It was a pleasure working with them along with Melissa Boston on that product. So today, I want to talk with you about how productive struggle factors into the things we've been talking about this morning. Issues of equity and how we create student agency and voice. I recognize that I am the only thing standing between you and lunch, so I am going to actually actively engage you in some activities that hopefully will stimulate you until the food can take over. So I'm going to show you a short clip. And while you're watching it, I want you to remember some of the things that you used to struggle with, and maybe you don't anymore, but also think of some things outside of what you're going to be looking at that you really struggled with when you first learned to do them. And it was only through time and effort that you got better at them.
Everything you're pretty good at now, you were once, well, pretty bad at. But you learned and got better.
Let's take the child diving into the pool. How did he get better? Well, it wasn't from listening to a lecture. It wasn't from sitting on the side of the pool. It even wasn't from watching Greg Louganis. So how does the child diving into the pool get better? I'm going to argue that he gets better from opportunities to work hard while getting guidance from experienced others, by engaging in what I'm going to call productive struggle. And I'm going to argue that that's how students get better too. So I'm going to start by saying, so what is this productive struggle and how can we support it? Well, I've started with the dictionary and looked up productive and looked up struggle and tried to think about how I might put those together to represent what it is I think it's at the heart of what I'm talking about. So productive struggle, working hard at something that's difficult to do, persevering when the going gets tough, and making progress. Key to productive struggle to me is when you reach an impasse on something, when you've gotten to the point where you think you can't go any further, getting the kind of support that's going to take you to the next step. So in Principles to Action, this was the first time we actually talked about productive struggle and its centrality, in our case, in learning mathematics, but I would argue that transcends disciplines and that it should be considered essential to learning. It develops students' capacity to persevere, and it helps students realize that they are capable of doing well with effort. Effort creates ability. Thank you, Lauren. So Hebert and Grouse explain it by saying students expend effort to make sense of mathematics, to figure out something that is not immediately apparent. The struggle we have in mind comes from solving problems that are within reach and grappling with key mathematical ideas that are comprehensible but not well formed. So the key here is the task on which we ask students to engage has to be within reach, but there has to be enough challenge that they can actually learn something that they don't already know. In our own work, this comes from the High School Taking Action book, we've argued that productive struggle comprises the work that students do to make sense of a situation and determine a course of action when no solution strategy is stated, implied, or immediately obvious. From an equity perspective, this implies that each and every student must have the opportunity to struggle with challenging mathematics, we've heard that word challenging several times already this morning, and to receive support that encourages persistence without removing the challenge. So when Ron was talking about this notion of clarity, clarity is great, but if clarity takes away all the thinking opportunities, we've lost the whole thing. And one of the things, unfortunately, is that students who have been historically marginalized are often placed in classes where all they do is practice rotely learned procedures and they never get a chance to struggle. And if they do struggle, they're immediately told what to do. Telling a child what to do may solve the immediate problem that you have as a teacher, but it does not do anything for the student. You do not build any kind of persistence, and more importantly, your identity as a math learner is going nowhere. You have no sense that you are capable at doing mathematics with effort. So we consider struggle to be productive if you've maintained the challenge of the task. So at the end of the day, were the demands of the task in place? Was student thinking supported and their effort acknowledged? And were students able to move past the impasse on their own actions, not on something the teacher told them to do? So there's been some research that I would say is in the area of productive struggle in mathematics, The first study is the only one that was specifically about productive struggle, but the bottom line is what they found is when you give kids challenging things to do and you give them appropriate support, they learn better. So the first thing I'm going to ask you to do is we're going to look at a teacher. First, we're going to look at the task he used, but what is the teacher doing to support students' productive struggle? So the teacher that we're going to be looking at, his name is Jeff Ziegler. Some of you might know Jeff Ziegler. He's actually a teacher in Pittsburgh Public Schools. At the time this was filmed, he was teaching at Langley High School, which is no longer a high school. He's currently teaching at Kappa. And the thing that's important about this, these are 11th and 12th grade students who are doing algebra. These are students who have struggled through their math work and through their high school careers. Some of them are taking this class for the second time. And he has chosen a task called the S pattern, which you have in front of you on the blue sheet. But there's a couple things I want to say about this task. First of all, before you get too nervous and jerky about it, really look at it. I would argue that this task is designed for difference. It is challenging. Look at the first three questions. What patterns do you notice in the set of figures? Is there anybody here in the whole room who couldn't notice something about the patterns? I'm going to guess not. Can you sketch the next two figures in this sequence? Describe a figure that's larger than the 20th one without drawing it. I would argue the first three questions are really all about making sure all kids have access to the task. So the differentiation here isn't I've got 10 different tasks that I'm going to pass out to students. I've got one task, and I have scaffolded entry in such a way that everybody can get started. We've referred to this as a task that has a low threshold and a high ceiling. Low threshold, you can get in. High ceiling, it gets to really important mathematical ideas. But certainly there's enough challenge here that students are left with something to figure out. This is certainly what we would call a high-level, cognitively demanding task, if I go back to the language of the Purple Book. And part of the challenge of the task comes from the fact that no matter how good you are in mathematics, there's no simple rule that you can pull out of your toolbox that's going to allow you to solve this. Because you really need to look at the figures and ask yourself what's staying the same and what's changing. So you're looking for the underlying structure of the pattern, and then you're going to use that structure to describe what larger figures that would be in the same sequence would look like. Okay. So I'm going to give you 1 minute, literally, to think about this. You can turn and talk, and I'm going to time us a minute. Okay, let's come back together. I recognize that that wasn't enough time to come to a full solution for many of you, but at least you got a sense of what might be involved there. I'm actually going to show you a couple of different solutions. See, isn't math fun? So what makes this problem so accessible is that the diagram itself provides a way of trying to think about what's going on here. So what you see in the very first one, I call it rectangle plus 2. You might have seen the figure as a rectangle with these two squares that don't change. So that's what remains the same. And then you could try to talk about how you would label the length and width of the rectangle. The next one, we call it the inner square, where you might have recognized there's an inner square and then a rectangle on the top and the bottom, and then trying to then talk about what the side measures of the square and of the rectangles. The next one is actually, we call it a bigger square, where you actually take it and you fill in pieces that are missing so that you can get a sense of what's going on here, and then realizing that you then have to figure out what the dimension is of the new big thing and what's the dimension of the original, so that you can subtract what isn't actually counted. The next one is actually rearranging the square, where all you're doing is you're moving one of the top row over, so you now have a square just plus 1. The last one is a table, which is a much less intuitive approach to this, and actually makes it very challenging to relate it to the figure, because once you put all the numbers in a table, you're now like in number land, and there's very little way to make sense of it unless you absolutely know the rule for how to create a quadratic equation from a table. We won't practice that today. So Ziegler's goals for his lesson, he wanted students to be able to write an equation, to understand that an equation can be written that describes the relationship between two quantities, that different but equivalent equations can be written to represent the same situation, and that symbolic and pictorial representations can be connected. Now, it's important to keep these in mind as you watch what he's doing. So just to give you a bit of context, the lesson began, students read the task, and they established the fact that it was growing in 2 dimensions. So they described it as getting taller and bigger. But before they began the work, he tells his students, now there are 6 prompts, kind of the first one, the second one, the third one. It's kind of to get you started. But it's on you guys to work with your groups to come up with a way to find the pattern. You don't necessarily have to word for word answer these questions, but they're there to help you maybe get started. So he's giving the students, he's saying, you decide what you need to do in order to get into this problem. And he's not going to go through the answers to 1 through 3. But if you need them, then you ought to be doing them. So the clip begins as he's told the students in small groups to begin their work on the task. We're going to see him visit groups 1 and 2. We're actually going to watch 2 separate clips. He's visiting them each twice, and we're going to watch the first time first. Okay, so you be thinking about what did he do to support his students' productive struggle.
The top is your X,
Line paper,
because that's constant.
plain paper.
That's all I was going to say.
You guys can decide what you want to
So
use to write on.
then you have to find a number that's before X to get to that. You already found what you have to add to get to that. Now do you have to multiply to get to that?
We figured this,
Not out a pattern.
but I can't do equations. I can't factor. So we figured that out first period. Can't factor.
Okay, so you're okay. So you're going to start with the table and see if you can find the equation for the table.
Yeah.
Okay.
But we don't know how. We don't know.
I don't even know how to start to find the equation.
We know what the B is. We don't know if it should be X plus 3 or X plus an odd. Like, because it's X plus an odd.
Right.
Because these are all odds on the bottom. They're
Right.
always going to be odd, and it's plus 2 between them. There's There's a difference of 2 between them.
Okay.
We already know this. The top rows are X. 1, 2, 3, 4. Like that's our X.
Right.
Our pattern.
I mean, if you could let
The
me
growth
see
is.
where you're at, like,
I don't know what the growth. That's
That's probably
the growth is an odd. It's like odd numbers.
Okay, so you have the table, you have these numbers written out.
Right. If we had the equation,
I'll be
this would
great
be
for
hard.
them.
Well, no kidding. Oh yeah, if I gave you the
You can graph
equation,
it.
life would be great.
on
What do you have?
this
Which is a what? S.
Okay.
picture.
It has what?
Here's
Okay. How many?
26.
Okay. And number 5?
Yeah.
Okay, that's 26. There's no other way you could come up with that number 26 than just counting.
You can go by like
So x
Or by
plus.
half.
He's leaving us. Wait.
Broke it down real easy, real simple,
Don't
because
take
it's
all the
obviously
credit.
it looks real simple. So
Do you guys know what he's doing?
Yeah.
Yeah,
top and
all
bottom.
help.
All right, well, hold on. You did
Okay.
this, so tell me what he did.
I think I know the equation. I remember doing it.
You don't know?
I was working by myself.
Oh, okay. Do you know what he was doing? Okay, what's
I
his?
know.
his whatever the pattern number is,
Okay.
not even looking at this,
Okay.
just whatever the pattern number
Right.
is, you take it and you times it by 2 because there's obviously 2 rows, and the top row and the bottom row both have this number in it too. And then you times that by 2, that'll give you the top and the bottom, and in the middle is a square. So
Right.
you do the well, I'm gonna call this x minus 1 squared. That'll give you the middle, and then you just add them together. It'll give you the
I
pattern.
understand them, I just can't explain them.
Did you understand that's it?
Yes.
And then I got another one though. If you take it and go this way, rectangle, you take x plus 1, and then you do x minus 1, and that'll give you this dimension right here.
Okay, just go back to the first one. There's. Look at what he's doing. Tell me what he is doing.
What do you mean, like?
When he came up with, when he was explaining with the top row and bottom row in the center, do you know what he was talking about?
Yeah.
What?
I don't know how to say it, but I help him do that too. Like, it's not just all him.
Okay. So tell me, show me. I mean, do you have it in your head? Is it on paper?
It's in my head.
It's in
He
your
said
head.
that, okay, the middle, there's one square in the middle, and then there's 2 on the top. Subtract 1 and to get the number, subtract 1 and square it to get the number of boxes in the middle.
Okay.
So, x minus 1, so 3 minus 1 is 2, and then you square 2 to get 4 in the middle. And then you multiply the whatever sequence you're on times 2 because there's a top and a bottom.
Okay. And that's how you came up with the equation. So, okay, can you take his equation, this 2x plus x minus 1 squared,
Figure 99.
and can you put it to a picture? Can you put it to these pictures? Like, let's pull out, let's say number 4, okay? If we take this, how does this picture right here relate to 2x plus x minus 1 squared?
So that's simpler than
And then you add 2
x
to the box. You
squared
see what I'm
plus
saying?
1. Yeah.
You see what I'm saying? Nick?
That's simpler
That's an
than.
easy way to break it down.
Yeah.
You go from, you just take these 2, not
Okay, so I literally want you to take a half a minute and write down something that you think he did that supported students' productive struggle. Now I'm going to show you his second visit to groups 1 and 2, and then I'll give you a little bit more time to chat with your elbow partner about that.
Okay, I'm back. All right, so when I left, I asked the group to come up and explain how we came up with 2x plus x minus 1 squared and where that relates in the picture. So you ready to tell me?
Yeah.
Okay.
Well, actually, I think that she made a different equation. I think hers is better.
we're just going to go
Yeah,
with this one.
the first one. Hers is x squared plus 1.
Yeah, but that doesn't explain the picture.
What I asked when I left was 2x plus x minus 1 squared. Fit the pattern, correct?
To fit the pattern.
Okay. What I wanted to know when I left was, how does it relate to the tiles? Where is 2x in these tiles? Where is the x minus 1 squared
Well,
in
x
these
is
tiles?
that number right there.
Okay.
And then 2, you just multiply 2 by that number.
Why?
Which gives you...
Why?
Because
about to be done as long as I can get 4.
The tiles.
because it gets
Well,
bigger.
we said we have a whole bunch
Doubles.
of square roots,
Yeah.
so it's not the answer.
It's probably good. That's why I said we have 2.5 or 1.5.
But yeah, it doubles every time.
What doubles?
The tiles. Like for 1, it doubles. And then for 2, it doubles. 3, it doubles.
It's the top and the bottom.
Yes, those two.
The X is the top row and the bottom.
What's the matter?
I mean, I understand, but I can't really explain it. Like those two.
If you want, see, my thoughts always were, if you really truly understood, then explaining would be the easy part.
Well, I do understand, but 2 is right here. That's where they got the 2 from. 2x. Like 2x, because you just take out those 2 and then use that. And then x minus 1 is like 4 minus 1.
No, which is 3.
3. Oh yeah, which is how much is in
9.
each row right there. Then you square it, and that's how much is in the middle.
Okay, so take the sheet of paper right now. Take number 4. Separate. I want you to actually manipulate those black tiles on here. Show me the 2x. Show me the x minus 1 squared.
All right.
Okay?
And then you add 1.
You listening?
Oh yeah.
Okay.
All right, you have 2 on the bottom, 2 on the top.
I get it.
You have that 1 in the middle, that's an extra.
Yes.
So you add that, that's
Yes.
plus 1, because 2 and 2 is 4.
Right.
That's 2 squared is 4. Then you add this extra 1 in the middle, that's 5.
Okay. What is he telling me here? Where x squared
Or
plus
is
1
he
came
asking
from?
me or
Yeah,
you?
I'm asking you.
Oh, I get it. It's like because you start off with 1,
Yes.
and then you turn the back over and then you add 1.
Okay.
And then you just keep going until you want me to keep going.
No, what I want you to do is I want you to take these black tiles that are sitting right here, and I want you to show me where do you see 2 squared, and then where's the plus 1 at?
Like
Where's the 2 squared?
right here,
What's that?
right here. These are 2.
Okay.
And then the ones in the middle.
Okay. So for number 2, for pattern 2, top row and the bottom row, you're putting those 2 together, making a square, and adding 1 to it. So if I did the same thing in pattern number 3, I took the top row and the bottom row, and I put them together. Is that 3 times 3? And is there 1 left over? So what I'm telling you is, how do you manipulate these tiles for your x squared plus 1?
I mean, because look,
If it obviously
look, 1, 2,
works.
3, 1, 2, 3, 1, 2, 3. Look, we're just doing it like that.
Where?
And there's the 1 left over.
You can do that.
Come on, I can do this. And then let's see the 1
can do that.
I'm not
Okay,
comprehending what you're
you
asking.
have.
4.
How many tiles do
And
you
then
have
there
in
go that
pattern
1.
3? How many tiles do you have in pattern 3?
10.
Okay. I'm giving you 10 individual tiles on this piece of paper. Okay?
You want us to
They are not touching.
Draw a new pattern?
I want you to take those 10 tiles and I want you to show me how you put them together to get x squared plus 1. That's what I want you to show me.
We could go like this. Look.
I'll be back.
Oh, just stay with us.
I'll be back.
Okay, so this time I'm going to give you a full minute to look across both videos and to see what you can identify as things the teacher was doing to support productive struggle. And you could talk to an elbow partner. Okay, let's come back together. So what did he do? I'm going to start by saying what he didn't do. Because most importantly, I think, is the fact that he didn't tell students what to do. He was not directive. Now, it would have been much more expedient if he had been. I mean, he was very patient with that first group. The first pass, they really were nowhere other than counting. The second pass, they actually had a generalization, which would satisfy a lot of people. But his goal was for them to make connections between the symbolic and the pictorial, and they were nowhere near that. So if he had told them what to do, look at a dimension, look for a figure that's familiar, try to relate the figure, any of those things would have taken ownership away from the students. It would have allowed them to complete this task more quickly, but it would not have left them feeling like they had accomplished anything, other than I survived another math class. Which some days may be fine for everybody, but that is not going to lead to the kind of deep learning that we're after. We might have also noticed that when he was talking to the groups, he got down on the level of the groups. He wasn't towering over them. We might have noticed his sort of comfortable interactions with students and how they seem to be very comfortable with him. So there are a lot of things like that that were going on in the class. From a more, let's say, focused on what the teacher did in a concrete way, he had clear goals for student learning. He was very clear, and I showed you what they were, about what he wanted students to do, and he kept pressing them towards those goals. So the goals provided sort of the beacon towards which he was driving things. He selected a task that had the opportunity for reasoning and problem solving, multiple entry points, this low threshold, high ceiling that I talked about. He pressed students to make connections. That was one of his goals. He asked questions that assessed what students knew and understood, because before you can move somebody forward, you got to know where they are to start with. So he asked questions, pressed them to explain, and then asked them to do something that was going to move them beyond where they currently were. And what's interesting about that is when he did that, he then walked away. And walking away, as you could tell, the first group in particular, don't leave us. But walking away really sends the implicit message that you are capable of doing this without me looking over your shoulder and breathing down your neck. And if we want students to develop persistence, then we have to give them space to persist. There may be a number of other things that you notice too, and they may come up as we continue through this. So I want to tell you about Group 1's ultimate success, because we're not going to watch any more video on this. But what's very interesting is you might have noticed the first time Group 1, they were counting. The second time they came up with x squared plus 1, but couldn't relate it to the picture. The third time he went back, students had come up with seeing it as a rectangle plus 2. So they gave up on x squared plus 1 because they couldn't explain it. And that led them to one that they could explain. So Ziegler actually asked the student, the male student who was the first one to speak in that group, to present during the whole class sharing of different solutions. So he went to the overhead and with quite a bit of confidence explained what they had done. And used the diagram at the bottom to help in his explanation. So through that, they actually emerged with a very viable solution to the problem, which could and did get connected to the picture. When we look at the whole class, he had all 4 of those major solutions we looked at a while back appeared within the class. That in itself suggests that the teacher was not telling everybody what to do. Because when teachers do that, guess what? Everybody has done the same thing. So what we saw here is 4 different solutions that were presented in turn and then culminating in discussion that pressed on the connections between the representations, the notion of equality, how these all could represent the same thing, and then why it wasn't linear. So one of the things, and I think this connects to some other things that have been said earlier today, we might call Ziegler a warm demander. And it's been described as a teacher who knows the culture of the students, has strong relationships with students, and commands that everyone in the classroom will be respectful and follow classroom norms. So there's this notion of caring, which we think is really important, but it's not caring in the absence of substance. So I'm going to hold you to a high standard, and at the same time, I am going to do everything within my power to help you meet that standard. And then Bondi and Ross also describe it as deliberate action to build a relationship with students, learn about students' cultures, provide clear and consistent expectations, and communicate an expectation of success. Now, I'm not expecting you to have gotten all that from 8 minutes of video, but you hopefully could see some of the things in those 8 minutes that would suggest the kind of teacher that we're talking about here. We also see some of the characteristics in his teaching of promoting identity. So promoting persistence and reasoning through problem solving. That is quite apparent here. Recognizing mathematical identity is multifaceted. This wasn't a task where, you know, being the fastest, the quickest, and the one who can come up with the one that I did is the one that's going to be valued, but rather looking at letting students find their own pathways and valuing those. Encouraging students to see themselves as confident problem solvers. I know you can do this. So, you know, I'm not expecting you to read this so before you start doing that. So Ziegler really takes this notion of relationships and identity pretty seriously. And he starts the year asking kids to write a math autobiography because he wants to understand where kids are coming from. So I'm just going to play this and let you listen to Jeff describe it.
I had the students write their math autobiography. So they had to talk about what their math identity is. So, you know, where are you now with mathematics? Why do you think you are there? What do you think has happened from the time that you can remember with mathematics till now? When did you find yourself shaping into the person that says, you know, I really love math. I think math is exciting. I think math is fun. Or that person that says, you know, I really kind of get that pit in my stomach when I have to come to math class every day. But there's a reason for that. Something happened along the way. Something happened multiple times that got you to this point. What was that? Because, you know, it's my responsibility to continue to shape their math identity. So if they really love math and they really enjoy math, so it's my responsibility to challenge them, but to hopefully keep them in that space. And students that come in struggling or, you know, really disliking it, how do I create an environment, a space, a year in which helps reshape that or form it in other ways that hopefully when they leave, you know, they're not just saying, I love Mr. Ziegler's class or I thought this class was great, but that I really got a new insight on what mathematics is and how I really do mathematics and how much fun it can be.
I'm not even going to ask how many have thought of math as fun, but I think you get what he's trying to do. So what's the takeaway from this? So I'm going to propose a model. This is not empirically driven, let's call it experientially driven. That challenging tasks plus appropriate levels of support, and here I'm talking about support that helps kids move forward without taking over the thinking, in a caring environment, so coupling those together leads to productive struggle, deeper learning, and hopefully the development of identity and agency. Okay, so now I want to engage you in another activity. This time we're going to first grade, which perhaps you will like better. So if you go to the green sheet, you will find a task that we call beads. And the beads task, because yours is not in color, the black dots will be referred to as blue in the transcript. The yellow dots or the gray dots will be referred to as yellow. Okay? So what we have here, and we're not going to take a minute to look at the task. I think we'll get the drift of it as you begin reading the transcript. So what you have is Mr. Klein's first grade class is working on comparing different types of addition and subtraction word problems. He selected the beads task because it was open-ended and will give him insight into what students understand about making comparisons and supporting their claims. First grade. Okay. In the dialogue, he's interacting with one group of students. So your question to be thinking about is, what did he do to support productive struggle? Okay, so take a minute and read the transcript. It's just on the front and back of the green sheet. And then another minute or two to talk with people in your group, and then we'll come back together. Okay, let's come back together. So there's a lot of things you might have noticed here that the teacher did. We saw some of the same sorts of things that we saw with Ziegler. There was a lot of asking questions. There was a lot of pressing. But one of the comments I heard over at this table that I really thought was interesting is he doesn't let the kids off the hook. So you just can't say something and then not support it. And so it's interesting to imagine that these are first graders. What would it be like if you got these students as sixth graders or ninth graders? I mean, you would have your hands full with people explaining things, but imagine the insights you would get into how students were thinking about the work they were doing and how much they had the potential to learn. So if you turn to the pink sheet, in her research, Warschauer has indicated 4 strategies for supporting productive struggle, and I think we'll actually see how these play out in this particular episode. So first of all, she says question, and we see all kinds of evidence of that. The teacher asks questions that help students focus their thinking and identify the source of their struggle, that encourage students to build on their thinking and look at other ways to approach the problem. Certainly Ziegler was doing this all over the place. So in this particular episode, students were really struggling to try to understand the reasoning of others, and they didn't agree on how to write a number sentence to match a claim. So he asked questions to focus students on the key ideas, again, without taking over the thinking for them. It's so easy in that moment to say, you know, this goes with this. But when you do that, you lose all sight of what students have actually taken away from the problem and the situation. The next one is encourage. The teacher encourages students to reflect on their work and support students' struggle in their effort, and not in just getting the correct answer. So he continued to encourage students to reflect on their own observations in order to explain their reasoning and ideas. So at line 9 is a good example where he pressed Sebastian to support his claim. Later on, he asked students to reflect on the meaning of 7 minus 5 equals 2 in the context of the problem. The next one is giving time. Teacher gives time and support to students to manage their struggle through adversity and failure by not stepping in too soon or too much. Again, we see the same sort of pattern we saw with Ziegler, where you give students something more to think about, and then you walk away and let them think about it. But what's important is coming back and holding students accountable for what you left them to do. Now, we saw a really great illustration of that in Ziegler's class. Okay, fine, you came up with another way. That's not what I asked you to do. And acknowledge. Teacher acknowledges that struggle is an important part of learning and doing mathematics. So struggling doesn't mean that I'm dumb. Struggling means, ooh, this is an opportunity for new learning. I'm trying to figure out something I don't already know. So each time he revisits the group, he acknowledges what students were thinking and gave value to students' contributions. So one thing to think about, these 4 strategies, how they might be helpful as you continue to think about how to support struggling students in your own classrooms. So what's the takeaway from all of this? We have to give each and every student needs the opportunity to engage in productive struggle, which means they need to have something to struggle with. The task matters. Just because I might not be good at multiplication doesn't mean that if you give me 20 of them, that's the kind of struggle I'm talking about. All students know something relevant, whether they recognize it or not. And I think this is really an interesting thing to think about. If you go to a student who seems to be doing nothing and you say, so tell me what you know about the problem. I don't know anything. Well, that's just a way to get you to go away or to tell me what to do so I don't have to think about it anymore. And what our job is to figure out what it is that student knows that can give them a foothold on the problem and get them moving forward. So teachers need to find ways to support students' learning without taking over the thinking. These 4 strategies might be part of what could be helpful. Teachers need to be warm demanders. There has to be a sense in which students know that you care about them, but you are holding each and every one of them to a high standard and sending the message that I know you can do this with support. And finally, this doesn't happen. Lessons like Ziegler's, lessons like Klein, these do not happen unless the teacher has carefully planned in advance, thought about the questions, thought about what kids were going to do, and how they were going to respond. So I leave you with, if there is no struggle, there is no progress. So thank you and enjoy your lunch.